Okay, and so continuing here, we've seen water, it can act as both an acid and a base in some situations, where we've seen water, a small percentage of all water will dissociate into H plus and OH minus. So we can see kind of some of the ways that we're going to act as, an acid and a base. And so here's one case here where water is acting as an acid. So our water is the source of this donated proton. So this proton here is coming from water. When we do that, we have our conjugate base left over, this OH minus, and where ammonia had the lone pair to accept that. In this case, HCl is reacting with water, and you can see here water is accepting a proton from the hydrochloric acid to form our hydronium ion, the H3O+, and we have Cl- left over as the conjugate base. So I want to compare some information about conjugates. And to do that, I want to take a look at two reactions here. So we have acetic acid, which is a weak acid, reacting with water, which is going to act as a base, and to the conjugate base of our weak acid is this acetate ion. So this acetate ion, and then for the hydrochloric acid and water reaction we just saw before, Cl- is our conjugate base. And so the acetate ion is a base. If we were to put this in solution, C2H3O2-, so we react this with water, what we're going to get, okay, so in this case water is going to act as the acid, and we're going to end up getting acetic acid and hydroxide. So we can see how we're forming a base here. With Cl-, if that same thing is going to be true, we would end up getting, HCl and OH-. Okay, but if we look at it, if we take a solution of sodium acetate, which is just going to be, sodium with this acetate ion to get it into solution, and sodium chloride. If we put this into solution, it's going to be the solution is going to become basic, something have like a pH of 9. If we put sodium chloride in solution, it's not going to have any effect whatsoever on our pH. And so we're going to see it's going to have to do with the strength of your conjugate. So the acetate ion, so acetic acid is a weak acid, and it's much weaker than HCl. So, but then the Cl-, the conjugate base, is really not a base at all. It's very weak, incredibly weak. And so what we see is this indirect relationship. So for example, over here we have our HCl, the strong acid, and its base, its conjugate base, Cl-, is pretty much negligible. It's not going to do anything. So very strong acid, incredibly weak base. Where if we have our acetic acid over here, and it's in the acetate here, it's a weak acid, but it's also going to be much stronger. It's a weaker acid than HCl, but it's going to be a much stronger base than Cl-. And so that works with a lot of different things. Stronger the acid, weaker the conjugate base. Stronger the base, weaker the conjugate acid. So we can see here some strong bases that have weak conjugate acids. Okay, and so I've mentioned pH a couple times here, and before we get to pH, what we need to explain is Kw. And so Kw, we've seen that water dissociates into H plus and OH minus. And there's an expression that's going to hold true here. Kw is equal to concentration of H plus times the concentration of OH minus. This product is always going to be equal to 1 times 10 to the negative 14. So if you have a lot of H plus, so if you increase H plus, you're going to have much less OH minus, so that this product is equal to this constant. If you have very little H plus, you're going to have a whole lot of OH minus to make it work. So if we're talking about just neutral water, where the dissociation, all of it's going to come from the same water molecule, this concentration and this concentration are going to be equal. So this 1 times 10 to the negative 14th is going to be equal to x squared, where x is the concentration of each of these, which is exactly the same. And so our H plus concentration, which is equal to our OH minus concentration, when we're talking about just pure water, is going to be equal to 1 times 10 to the negative 7th. And that's going to be important in just a second here. Okay, so pH here, this is the equation for pH here, and before I get to pH here, I want to explain logarithms and what they are. So we'll pick this up in the next recording here.